All right. So tonight we are going to study new chapter 8. We are going to talk about a new concept, everybody. We call this hypothesis testing. This is a very useful technique in the industry, especially the pharmaceutical area, right? When those pharmaceutical company develop a medicine, they want to test, is that medicine significant, effective or not? So usually there are 4 stages for them to do the test. So you probably hear these like phase 1, 2, 3, 4. So usually it takes several years for them to develop. They have each phase, they have to do this clinical trial. You probably heard about that, right? I mean, nowadays the virus, there are several companies trying to do the clinical trial, right? So the same concept here, everybody, hypothesis testing. So in other words, you can apply what we learned today directly to those pharmaceutical companies. They are trying to do the test. So in other words, the skill we are learning today, potentially, if you are working in those pharmaceutical companies in the future, you can apply them directly. All right. So let's see. The first piece, we want to understand what does that mean for hypothesis. So there are 2 kinds of hypothesis here, everybody. Recall the fundamental application for statistics is to make reference, conclusion from the whole for the whole population based on the sample, right? So in other words, for example, the clinical trial, based on the testing patients, how do they react to the medicine, right? So there are certain degree of effectiveness we can measure. So they submitted the data to the FDA. FDA using exactly the skills we are learning tonight, right? To determine if the medicine is effective or it's not, right? So let's continue. So to help you understand what is a null hypothesis, what is a alternative hypothesis, everybody? I'm trying to see if I can get this bigger. Right. Can everybody see my screen? Is that clear, or should I get make it bigger? Oh, that's too big. I think that's a little bit better, right? So in terms of null hypothesis, alternative hypothesis, you can understand that as 2 statements. 2 statements. So we are using examples here to understand that. Say we have a sample of 50 patients. We want to use the results from those 50 patients to determine the average, the pass rate for the patients, right? After the medication, is that 82 or not? So that's the statement here, right? So those 50 patients, they are using the medicine. So after the medication, they want to see the average rate, right? Is that 82 or not, right? So that's the statement here, including, the both sides. So everybody, we always start with the null hypothesis, everybody. We are using the notation, capital H for hypothesis. 0 means the null, right? Null hypothesis, everybody. How do we understand that? We understand that null hypothesis always equal. So in this case here, we are trying to determine the average rate. Is that right, everybody? So we are using the, remember, mu is reserved for the population average. Is that right? So we are trying to determine the population average rate. Is that equal to some number which is given here, 82, or not, everybody? That or not tells us that is an alternative hypothesis. And we are going to use the notation capital H1 for that. Is that clear? Any questions? Right? So we have this alternative hypothesis. Mu is equal to some number. That number usually given, like in the statement, like something you got from the historical data. And then H1 is something not equal, determined by this statement, right? So now what if I change this statement a little bit, everybody? I say, I want to test the average rate is 82 or bigger than 82. So you see that statement change a little bit. That also changed my alternative hypothesis. So null hypothesis H0 always the same. Everybody here is always equal. So if that helps you. Everybody, for the coming homework, most likely the coming exams, most likely there might be one question. So you have to write down the 5 steps in the hypothesis testing. The first step is to write down what is H0, what is H1. So everybody, there will be one question at least. So not everything is a multiple choice in the future exam. Okay, there might be one. You have to write down H0, H1, right? So now if we think about this statement here, they are saying the average rate is 82 or bigger. So in other words, you see the H1 becomes what? Becomes mu is bigger than 82. Is that clear? So what if we continue to change the statement, right? So the average rate is 82 or lower than 82. So in that case, you see H0 always equal. Everybody? That is a shortcut if you want to remember. H0 always equal, right? And then H1 determined by the statement. So this case here, we say lower than 82. So it's less than 82. Everybody, 3 situations we will cover all 3 later on, case by case, right? So to give you an idea here, when we say H1 is greater than 82, that means what? It's to the right, is it right? So it's equal to 82 or bigger, so it's to the right. What do we call this kind of a test? We call this right tail test. Let me see if I can use some hold on, where is the, can I, oh yes, is this one? Yes. Right, this right tail test, right? Format, let me see, do I get some color? Yeah, so this is right tail test, is right to the right, right? And this is to the left, everybody, to the left. What do we call this? Left tail test. And then if it's both sides, that means what? That means the middle is 82. Could it be here or could it be here? So we call this two-tail test. Is that clear, everybody? Any questions? We have more examples here. You can understand it better for those examples, okay? Because one example may not be enough. So let's continue. Other examples here. Let's see. Hold on. Yes. All right. Now, why do I have it that big? Okay. Thing is to somehow, why you see, no, no, 3 pages together, right? Let's not do that. Hold on, let me, okay. Yes, let's do this one. All right, so more examples here. You understand better what we are talking about here, right? So a researcher thinks that if the expectant mothers use vitamin pills, the birth weight of the baby will increase. So that's the hypothesis they have, right? So given the average birth weight is 8.6 pounds. So in that case, everybody, when we write down a long hypothesis, right? So you can write down like H0. You don't have to write down long hypothesis, but you do have to write down H0. Remember, that's always equal. So the average weight for the baby, so mu, remember, that's the average, right? Equal some average we are given here, 8.6. That's easy, right? Alternative here, determined by the statement. So here we are saying increased. Everybody, When they say increased, that means it's bigger than 8.6. Is that right? Everybody follow me? So that's easy. Number two, some NGM hypothesis that the average number of defects can be decreased in the process of compact disk by using robots instead of human being. The average number of defective disk per 1,000 is 18. So when we write down what is H0, what is H1, remember H0 is a null hypothesis, right? Always equal. So we are using a letter, everybody, most of the time, we are using a letter mu for that. Mu equal to 18. So you will see, I think most of time, unless later on there's one section, we are using a different letter. Otherwise, we are always using mu, right? So that's easy, equal to some number given. Now, H1 determined by the statement here. There's a keywords you are looking for. You are looking for the keywords from a statement. They say, like previously, here tells you increase. This case here tells you decrease. That means what? Less than. Right? So you see the difference? So that's what do we call this? Is to the left or to the right? Everybody? Anybody can type the answer? Hopefully that wake up some people because online here, right to the left tail. Yeah, good. Street, Line, good. Harry, Jose, Arturo, Kalari, Sikai, yeah, good. Yeah, try to wake up, everybody. I understand the online class is not easy, right? So try to have a good position. Do not lay on your bed, right? Otherwise, easy fall asleep, right? Because this voice here sometimes is easy make you sleep. Sometimes I feel that way. All right. Example number 3. A psychologist feels that playing soft music during a test will change the results of a test, but not sure is that higher or lower, right? So in the past, the average score is 73. So based on those information, we can write down H0, that's non-hypothesis, right? Mu is equal to what? 73, right? That's the one we are given here. H1 determined by the statement, right? Previously, we say it's higher or lower, then we can decide it's bigger or less than. This case here, they did not say that. In fact, they say it's not sure. So in that case, by default, it's not equal to. So we call this two-tail test. Follow me. All right, so that's the, in terms of hypothesis testing, we always require to write down what is H0, what is H1. Everybody, that's our first step. There are altogether 5 steps in the hypothesis testing. Okay, that's our first one. Now, here's some example to help you understand. In stats, if you are learning more statistics, there are some concept called like type 1 error, type 2 error, to give you some idea. So this example here is using the jury trial example. H0, in this case here, we say the defendant is innocent. So that means it's not guilty. H1, the defendant is guilty, right? So that's H0, H1. And you can see that table here. So if H0 is true, that means that person, the defendant, is innocent. So that's this this column here. Everybody, this column here. Let me try to draw something. This column here, right? This person, if we know that's innocent. But the jury outcome is coming from here, right? Say the jury outcome say the defendant convicted, right? What do we say? That means the defendant is, in fact, the defendant is innocent, but the jury say it's guilty, we are making mistakes, right? So this is what we call type 1 error, type 1 mistakes. We want to control that, right? So if the person is guilty and the jury say, yes, it's guilty, they are making correct decision. Follow me, right? If the person is innocent, and then if the jury say innocent, right? So what do you call this? This is a difficult word for me, right? So it's innocent, that means, right? So they are making correct decision. But if the person is guilty, the jury say not guilty, we are making mistakes. So we call this type 2 error, everybody. The corresponding probability, we are using this letter beta to indicate that. Remember this alpha we mentioned before, right? So previously we say, what's alpha? Alpha is the probability of making mistakes, right? Given 95% of confidence, we have 5%, which is the alpha, right? Alpha is 1 minus the confidence. So that's the 5% of mistakes. To be more accurate, it's 5% of the type 1 error, right? So instead, we want to control both. We want to be alpha to be small, also beta to be small. So here, everybody, this one is to give you some basic idea of type 1 error, type 2 error. This one here is not required for our class. So if you got confused for this beta, especially for beta, that's totally okay. Okay. Now, let's move on. Another example to help you understand better in terms of type 1 error, type 2 error. Okay. Let me erase the stuff here. All right. Right. There's another case. We see that in the reality, right? What do we call this? The test, right? If someone is like a pregnant or not, right? So usually there are some like a testing device, right? I mean, as simple as like one simple device, or as complex as like you have to go to hospital to get some blood for testing, like that, right? I mean, so you can see that there's always a chance of making mistakes, right? So in this case here, we say H0, which is our non-hypothesis, right? The person is not pregnant, right? The regular situation say, not pregnant, H0. H1, the person is pregnant, right? So if the person is not pregnant, but then if the device testing output say is positive, it's showing pregnant. So in that case, that positive, everybody, is what we call false positive. Is that right? So to help you understand better, what's type 1 error? What's type 2 error? So type 1 error is false positive. Type 2 error is false negative. If that helps you understand better, what's type 1 error, type 2 error, everybody? So that's this concept in terms of if we want to understand type 1, type 2. Now, let's continue. There is some concept here we want to introduce. You probably see that already from the homework. And I want to briefly mention that here is this one here. From the homework or from the exam, right? So last time we say we have the confidence interval. For example, if we talk about a 95% confidence interval, right? So that means we have the middle part of 95%, 2.5 on each side. Is that right? Right? So corresponding value, remember, 2.5%, 2.5%, middle 95%, corresponding Z alpha divided by 2 is what? 1.96. So some concept here I want to introduce. This 1.96, what do we call that value? We call this critical value. Critical value here, everybody. So you have positive 1.96, negative 1.96. both what do we call critical value. Now, what do we call this region here? Like this 2.5% here, this region here, also this region here. What do we call them, right? So we call them critical region. So if you see that from the homework, right, you understand this concept here, everybody? Critical value, that's like a Z corresponding to, right? Critical value, right? Z. You can find out from the Z table most of the time, right? And sometimes you later on you will see, sometimes we have to find out from T table, okay? This region here is called critical region. So my question is, what do we call this region? Anybody knows that? You can type from the message window. What do we call this in the middle, this region here? This region, right? So that is called non-critical region, right? Non-critical region. Somebody try to speak. Chris, Danny, are you able to connect, or do you want to say something? All right. So that is for this concept here. You will see that for the upcoming homework. All right. Let's erase that. So that covers our 8.1, I think. Let me see. Right. There's no more pages, right? Any questions, everybody? Any questions I can help answer? Otherwise, we are going to move on to 8.2, which is the, we have Astrid ask this question here. Would you be able to review the 5 steps? Yes. Astrid, we just introduced the first step, the very beginning. So now we are going in the details to cover the 5 steps in each of them with more details. Okay, let me make sure that somehow I cannot move this. I don't know why is that. Okay, it's here. Yes. So 8.2. We are going to officially introduce the 5 steps. Everybody wake up. This is so important. So remember, if you understand one example very well, the other examples are very similar. Okay, so wake up. We have 5 steps in the hypothesis testing. So first step, step number 1. So we have to write what's our goal, right? What's our target? We want to be very, very crystal clear, right? So we write down what is H0, what is H1. So we have done that in the previous section, 8.1, right? Step 2, we have to do some computation. We call this test value. So in other words, there will be some formula we have to follow to use, right? Step number 3, which is something that you might get confused here. What we call p-value. We are going in more details later, okay? Number 4, make a decision. Number 5, summarize our results, right? So let's use our examples here to understand better. What are those 5 steps? Everybody? This first example here, we are going a little bit slow. After this example, we may take a break, okay? So claim the average cost of college is greater than $5,700. Like that's the goal, that's the hypothesis they want to do, right? So always you want to show something, you want to prove something, right? You need to get some data, some sample. So they randomly select 36 people, 36 students find out their average cost of college, 59.50, right? The population standard deviation is given 659. Question, is there any evidence to support the claim? And that one is, what's the claim? Claim is here, right? At alpha equal to 5%. Everybody, there are a few things we want to make sure we understand clearly here, right? Based on the sample, based on the 36 people itself, what's the average cost of college? Is 59.50, is that right? So that number 59.50 is bigger than 5,700. That's 100% for sure. Is that right? So in other words, we are 100% confident that just 36 people, their average cost of college is bigger than 5,700. We are 100% confidence. My question is, if I say overall, all the college students, how much confidence we say all the college students, their average cost of college is greater than 5,700. You see that? Then in that case, you don't have the 100% confidence anymore, right? You may have, say, 80%, 70%, right? So depending on what's the confidence you are talking about, right? So we are going more details here for that confidence, okay? Now, step number 1, write down what is H0, what is H1, right? So H0 always equal, everybody. So we are saying mu is equal to 5,700, right? Equal to certain number here. What's the number? The number should be given from the statement. Something you want to compare to. Be careful, everybody. You don't want to write down 59.50 here. And this is a common mistake. Okay. You want to compare some number which is greater than some number here. Use that number. Okay. Now, H1 here determined by what? By your goal, your statement, right? They are trying to see the claim. The average cost is bigger than. That means what? Bigger than. It's to the right. Bigger than. Right tail test. Easy, right, everybody? So far, so good? Good. Now, step number 2. We want to do some calculation, right? The test statistics. Which formula we are using? We call this z-statistics. Everybody? You probably have seen that before, I think. Is that right? Did you see that before, everybody? This formula here, this one. I think we did mention that is a central limit theorem. Is that right? Yeah. So that formula, in other words, is not that new for us, okay? So we are using the same old formula here. We are using the Z formula because we are given the population standard deviation. Everybody? That's what? That's a sigma. Right? Whenever you are given sigma, you are using Z formula. So this formula here should be available on a formula page. So it's equal to X bar, sample average minus mu divided by sigma over square root of n. Everybody? Let's plug each number here. What's the X bar? The sample average. What do we find out? 59.50. Is that right? So we put that here. Question. What is the mu here we are plugging number here? Be careful. We are using 5,700. Why? We are using the number directly coming from H0. You see, that's the reason. We always require H0 to be what? Equal. Why? Because when we have mu is equal, we can put the number here, replace that number. You see, right? Standard deviation, sigma, square root of n, sample size 36. We got that, 2.28. We got the calculation statistics. So we call this test statistics. So far, so good. Now, step number 3, which is a little bit confusing here. All right, follow me. This one is going to be a little bit challenge, okay? Let me try to go slow here, okay? You don't get confused. So after we calculate the test statistics, we are going to find out what's the p-value. So there's one question here. It's not that straightforward to answer, right? What do you mean by p-value, right? Let's use some example here to understand this. Everybody, from this example here, once we find out 2.28 from the test statistics, right? This one here, 2.28. So we can draw the bell-shaped curve, remember? Right? Because that is what? That's a Z, remember? That's the standard normal curve, center at 0. Then where is our value? 2.28. Say somewhere here, right? 2.28, everybody follow me, right? So what is the p-value coming from, everybody? P-value is determined by H1 here. Follow me? So H1 here tells us mu is greater than 5,700, right? So what does that mean? Greater than 5,700, that means to the right. Everybody, this is very, very important. I need your attention here. If you are falling asleep, try to wake up. Because that's a tricky part. How do we find out the p-value? Determined by this number here, 2.28. Is that to the left or to the right? Determined by what? Determined by H1. H1 tells us it's greater than. That means what? To the right. So in other words, we are trying to find out the probability to the right of 2.28. Follow me? Should I mention this one more time, everybody? Let me see. I want to get a feedback from everybody. Do you understand this piece here? If you understand, type yes. I'm trying to see who did not type. I'm going to ask that person, okay? I think there are still a few people. They are not answer yes. Gavin, do you understand why? Olivia? Okay. Cami, okay. Sanim for Jackie? All right. All right. So that's the concept here. What's the p-value? How do we find out the p-value, right? Later on, we are going to give an intuitive understanding what's the p-value. So right now, it's based on the calculation, right? From the graph, determined by the p-value, determined by, like to the left, to the right, determined by H1. Okay, determined by H1. So how do we find out this area? Everybody remember, how do we find out this area, this probability here to the right, right? There are two ways you can find out, right? So we have to use some table to find out that. Can you tell me which table? Can you type your answer? Which table you want to find out the corresponding probability here? Z table, that's right, right? Yeah, yes, Z table, right? So we are trying to find out, remember there are two ways to find out the probability. The lazy way is using what? The corresponding negative 2.28. Right? Because we know this area here will be the same as this area, right? So this area, we can read that directly from the Z table, right? So let's see, where is my Z table? That's this one here, right? So we have 2.28, right? So negative 2.28. And let me erase that, otherwise it's too confusing here, right? All right. So 2.28, well, let me see. So 2.28, let's see. So negative 2.2, remember everybody? Negative 2.2, so this column here, and then up to 8. Where's 8? This one here. Follow me? Right? So that 2.28, negative 2.28, that give us the corresponding probability, 1.13%, right? 1.13%. Let's see, where is my, I'm trying to get my, hold on, trying to get my PDF here, okay, bear with me. Because I opened so many windows here. All right, hold on. Let me erase that first, right? So what do you have is, let's see. Yeah, let me erase that one. Hold on. Okay.